We have Sam Gramling. Sam is the sitting president for the International Grooving and Grinding Association, as well as the president of the Concrete Pavement Association in Minnesota. He's been doing interstate improvement work for over 10 years. I give you guys Sam.
As she mentioned, right now I'm the president and chief operations officer for a company called Interstate Improvement we're actually located out of Faribault, Minnesota. I have had the honor and the privilege to work with almost every DOT that's represented here, I think with the exception of maybe Kentucky and Tennessee. But I'm kind of pulling a little bit of an audible on what I was originally going to discuss. I have a rather lengthy slideshow here of do's and don'ts on concrete repair and things like that. But to be perfectly honest, I stole pretty much the entire slideshow from the IGGA. The IGGA is actually represented here for the rest of this week with a Mr. Larry Schofield, who's not in the room right now, but we'll have a exhibit set up across the hall there, and he's kind of the show pony for that sort of stuff. I'm not. I'm a contractor, so I'm a little more deliberate and a little more straight to the point. So what I really want to do here is I'm going to breeze through a lot of these slides and probably just click through them before you even get a good look at them. I can make this presentation available to anybody that wants it. Tonight after I'm done, I plan to sit with Mr. Schofield over at the IGGA table. If you have any specific questions or anything like that pertaining to the kind of work that we're looking at doing. Interstate Improvement, I'm the current board president for the IGGA and the current board president for the Concrete Pavement Association of Minnesota. The IGGA, contrary to their name in terms of the International Grooving and Grinding Association, would be what I would consider the nation's, one of the nation's leaders in all concrete preservation techniques. So they are the go-to people if you have questions on what you should be doing or shouldn't be doing. Just a little bit of a background, kind of the theme of what everyone's been talking about here so far. Obviously, our infrastructure, we greatly underestimated our future needs. We're left with what we're left with right now. Our growth is outpacing what our road construction is able to do. Our highway funding fails to keep up with the needs that we have to have, and we're carrying a lot more traffic for a lot longer than what was anticipated. We've seen a shift over the last few years in terms of what is prioritized for certain projects. And the message that I want to get across, I guess, is that when it comes to concrete repair, we're fairly undermatched when it comes to asphalt and other aspects of our industry as a whole. But we are not absent at all in terms of what these priorities have shifted, and we certainly can provide certain things that we need to do what you see here, the increased safety, the added operator comfort, save money, protect the environment. These are all focuses that we're doing as an industry as well as some of our competitors and everything like that. The big thing here is that pavement preservation, the philosophy is keeping good roads in good condition. If you were to reach out to myself or most competitors that I have, if they tell you that they can fix every road with these techniques, they're lying. It's that simple. These are techniques that are very specific to very certain types of roads and at certain points in their life cycle. So if you have questions, what I'm urging everyone to do is reach out to myself, to my competitors, to the IGGA to the local ACPA chapter and ask these questions during the design phase. Ask them early and ask them often about, hey, I have a specific project that I'm looking at, and I want to know if it's a good candidate for a concrete repair. I've been to dozens of places around the country, meeting with dozens of engineers well before there was even a project that existed. And I've walked out with some of my competitors, and it pains me to say, that are equally as capable as I am or my company is. And we physically walked the roads and been asked the question, well, what would you do here? What do you think about this? Can we do something like that? And in simple questions like, looking at this road, what are some things that you guys could suggest that would save us money but still give us the end result that we're looking for? Still give us that 15, that 20-year fix. And we're more than happy as an industry to certainly explain that. The preservation techniques that our company specializes in, and in the things that I can sit and honestly say the do's and don'ts to, are listed here. Cross-stitching longitudinal cracks at joints, partial depth repair, dowel bar retrofits, full depth repair, diamond grinding, joint and crack resealing. There is undersealing / slab jacking that also generally falls into those preservation techniques. It's not something I do, and it's not something I know a whole lot about, so I'm not going to claim to know anything. Just a couple of quick things here. Cross-stitching. You can see here there's a list of what it does and everything. The one thing I want you to take away from that is the key word on this is used to maintain aggregate interlock. If the interlock is already gone, the cross-stitch is pointless. It's not going to give you the design fix that it's supposed to give you. If you have a longitudinal crack that's already an inch wide, the aggregate interlock is completely gone, either repair it or seal it and hope for the best. I mean, it's really that simple. And these are the sort of questions, the pictures and things that you can ask myself, you can ask the IGJ when you are in the design phase of something. Some of those picture ones, like I said, I'm just going to kind of breeze through these standard drawings and things like that, but because I want to try to avoid some of that technical aspect of it. Larry Schofield now, who's in the back of the room, is the guy that you want to talk to when it comes to specific questions like that. As you can see here, they're just drilling. They've drilled in along those cracks. If you look in what would be your top right corner where they painted out that yellow crack that they're stitching, notice how tight it is. Notice that it still has the aggregate interlock. Everything is still there. If that's one of those gaping, we've done it. We've done longitudinal joints where an on-ramp meets the main line, and it was built after the fact. The interchange was built later, and it was never tied to the main line, and it's drifted to an 1.5 or 2 inches wide. It'll hold temporarily, but it's not the 15-year or the 20-year fix. The understanding needs to be there that it's not the 20-year fix that you think. It might be a 7-year fix. Slot stitching is another form of the cross stitching. It's a little more. It's usually quite a bit more expensive because the slots have to be sawed in and then hammered out, as opposed to just a simple drill in. Partial depth repair. Something to look at here, where it talks about is the upper 1/3 of the slab. Too often when we're out doing partial depths all around the country, we tend to see people wanting to use the partial depth repair as a fix that is well beyond that. If we don't do initial sounding of the concrete to see what's actually there, and I think I have a slide on that, initial sounding of the concrete, what happens more often than not is we either mill it, we saw cut it, we start jackhammering it and opening it up, and it goes from a 3-inch repair to a misshapen V-shape down to, right down to the subgrade. And we've gone from the realm of just what it is, a partial depth repair, to basically doing a full depth repair using the partial depth model. And it's costly. It's costly for both the contractor and the owner, and it doesn't give you the fix that you're wanting. The best thing for that is really looking at in the design phase of it, sounding the concrete, do some core drills, whatever needs to be done to know what you're having there. When it gets pretty expensive when you're dealing with the contractor already on site, going, I think we need to make some changes here because we're well past what we thought we were past. Spalling caused by dowel lockup, spalling at working cracks, they're not good candidates for partial depth repair. A lot of projects that I've been on are on pavements that are 50 years old, 70 years old, and we're doing a partial depth repair. It shouldn't happen. I mean, it's not the right repair for that type of application. Or another good example is we're working on a project in South Dakota right now that they had used a dowel bar inserter during the paving process, and that came out that 15, 20 years ago when they first started happening, and they've got dowel bars everywhere. I mean, most of their joints are locking up, and they've got us out putting partial depth repairs on them. If we're filling in a spall that's created by a locked joint, the spall's not going to last. If you don't fix the locked joint, it's not going to last. And it sounds simple enough. It seems like a common, some common sense things there in the design phase, but unfortunately when budgets are brought in and really looked at, and they look at something and they go, okay, well, we just need to put a Band-Aid on it. Well, it's certainly capable of doing, but you're not going to get, again, you won't get the 15 or 20-year fix. So during that design phase, if you're talking with a contractor, if you're talking with an organization, reiterate what you're looking for. If you're looking for that 20-year fix, the industry should be honest enough with you to tell you whether or not you're going to get it. And they should be able to give you a pretty good idea of the dollar amount it's going to cost you to do that on a certain section of road. I know I'm certainly pretty open on those sort of things that with owners that have reached out to me and said, this is what we're looking at. Going through a quick 6 steps of the partial depths. Again, determine the location of the patches. You're going to remove the deteriorated concrete. You're going to prepare the surface, place and consolidate patch material, finish and texture, and then open to traffic. When I say sound the concrete, these are some demonstrations above, and this is a skill set that is fading fast. It's difficult to know what you're listening for and what exactly it's supposed to sound like when you're dragging the steel chain, when you're hitting it with a hammer, to know if there's a void there, if you're hitting that dense, dead concrete. It's not, to be honest, it's not even a skill that I'm very good at. I've done it time and time again, but cores are much, much more valuable. And what we've seen, if you take a specific a particular road and you look at a joint that you would look and say, visually, I believe this could be a partial depth. It looks like a little bit of surface deterioration. Let's go ahead and put it. Core it and see what's happening. Sometimes sometimes you end up with the bell shape where it looks okay on the surface, and by the time you get down to the subgrade, it's completely void. There's all sorts of different things. How often has it been sealed? Has the sealing been maintained? Was it ever sealed? All of those sort of things are going to tell you what's actually happening below the surface. But you do a core, at least you can look at it and go, all right, if this one looks good, I can safely assume that further on down it's gonna continue to look good. This was all poured the same time. It can't be an anomaly that this is the top 3 inches of our 9-inch pavement. If you are looking at you take a core and that runs all the way through, we go back to the drawing board. We figure out ways that we can do the repair, still keeping it repair, still keeping that life cycle that you want out of it, and at least somewhat keeping it in budget. Again, during the design phase, so much better to do. With the repair dimensions, they always talk about trying to go a little bit beyond that. Takeaway here, don't be too aggressive with partial depths. Couple of different ways you can perform the partial depths. Number one, you can saw cut around them and jackhammer out. The pros to that is that you have very little spalling around the pavement. Most crews that you're going to find are more than capable of doing that. The cons, you've got some water. Slurry in our industry is a nightmare to deal with. The water is there, has to be contained somehow. There's some polished vertical edges when you saw cut. You polish the aggregate and everything else, and that leads to some possibilities of poor bonding. And they're expensive and time consuming to change. If you find out after the fact that you didn't mark near enough of the deteriorated concrete, it's expensive to bring saws back, resaw, everything else. The cold milling leaves a rough, irregular surface that promotes the bonding that you're looking for. It is quite a bit faster and cheaper. It's just not as common. So when you look at the cons, it's really not as common. There is some spalling that will happen along the edges, but even those slurried correctly and poured correctly, the chipping and spalling goes away as well. But it's just not as common. So it's a little bit harder to find the quality contractors to do it. I'll skip that. Irregular shapes are acceptable doing partial depth repairs. Cleanliness is the number one thing. Making sure that it gets out there, making sure that it's sandblasted correctly, the bond is everything. The patch material from one to the existing roadway is in getting that strength is important, but bonding it to the existing roadway is everything when it comes to the success of a partial depth. You can do a cement-based mix or a non-cement based. Cement-based mixes are definitely cheaper. They are unfortunately, here, let's get to this one. The non-cement based mixes are more expensive, but they offer greater flexibility. They typically will last not necessarily longer, but they'll last the same type of many years that you're looking for. The 15 to 20 year mark is what we kind of always peg for these types of repairs, but they are considerably more expensive. Sometimes they're a necessity when you're looking at things like the shortened work windows that we're dealing with now, night closures, stuff like that. Anytime you can stick with a cement-based, your costs are going to come down, but you lose some of that flexibility in terms of your working restrictions, your time frames, that sort of stuff. Again, some pictures that I can get you at any time. But I'm going to try to do my best to get us somewhat back on schedule here. Dowel bar retrofits is a placement of load transfer devices across joints or cracks of existing pavement. Anywhere you have poor load transfer, this is always a good candidate. However, and something that you'll hear me talk about a little bit later is economy of scale. Dowel bar retrofits is probably one of the biggest issues in terms of our type of work, that without the economy of scale, it almost prices itself out. To go in and take a 15-mile road and say, you know what, we've got a handful of transverse cracks that we want to just make working joints, we want to put dowel bar retrofits in them. There's going to be, Indiana is a state right now that's doing a lot of them, is going to be, we're going to put 1,200 of them on this job. This takes specialized equipment. It takes a specialized saw to saw those slots, and some skilled laborers to hammer those out and pour those retrofits. doing 1,200 of them, you're basically shooting yourself in the foot instead of doing just a full depth patch and making it a working joint that it wants to be. With the economy of scale, this is a type of fix that needs to be a mass production. This is something where we have jointed concrete, but it's on-doweled, and we have that poor load transfer on a series of joints through the course of a stretch of road. You put this out there, and you can get some pretty competitive bidding, some pretty competitive pricing on it. It's not to say that you can't, but the last round of bidding on the Indiana DOT is, I think the average bid price for the dowel bar retrofits that were coming in that were 1,200 dowel bars, things like that, was around between $85 and $95 a bar. We're putting 33,000 dowel bar retrofits in Grand Forks, North Dakota right now that are coming in at about $32 a bar. So more than double to see that kind of influx in the quantity that you have. The material's the same, the saw cutting's the same, the specifications for the most part are the same, but just that economy of scale is almost twice as much for doing that few of them. And that economy of scale goes for all of these techniques that we're talking about: partial depths, full depths, retrofits, grinding, the whole thing. You want lower prices? Find more roads to fix. I mean, as an industry, we don't care. Throw 3 or 4 stretches of road into one contract, and just so that you can add more quantity, draw in more people, draw in more competition, you will get much, much lower prices. So, as I said, the purpose of the dowel bar retrofits to reestablish the load transfer. And something that I'll get to a little bit later with the diamond grinding, I would highly recommend, if you're going to do dowel bar retrofits, that you diamond grind it as well. It should be a 1 and 2 thing there. 4 main operations: cutting the slots, preparing and placing the dowel bars, backfilling the slots. Here the biggest thing is make sure that the dowel slots are aligned properly. A crooked slot putting in a bar crooked defeats the entire purpose. I mean, you're taking a joint that has poor load transfer and you're locking it completely. So you're basically forcing a point that it wants to blow up. So in terms of inspection and everything else, make sure they're doing it correctly. Make sure they're cutting it with a gang saw, not one slot at a time. You should be cutting 3 slots at a time with the saw that's measuring off the center of the roadway. And it should be straight. It should be running parallel with your center line so that everything works appropriately. Again, the alignment is critical. You can do it in transverse cracks. You can take that and make it a working joint, but make sure the cracks aren't too far gone. That it shouldn't be a full depth. I mean, if it still has that aggregate interlock and everything else, yeah, you can make that a working joint. It obviously it cracked there for a reason. It wants to be a joint. Again, as I mentioned, DBR followed by diamond grinding is really key. The best way to do a dowel bar retrofit when you're finishing with that type of thing is to finish it high. It needs to be finished a little bit elevated from the original pavement so that you don't have it pull away from the side of the slots. And if you're going to finish it high, you're going to want to grind it off, and you're going to want to take that load transfer, that faulting that you see in a joint. You're going to want to take that off after you put the retrofit in. That's the best way to optimize the full life of the retrofit patch. I'm going to skip through the Washington State DBR research. Full depth repair. Full depth repair is obviously the best type of fix that we can do. If you're given an option between partial depth, dowel bar retrofit, simple joint sealing, cross stitching, slot stitching, or full depth, you want full depths. I mean, it brings it to the subgrade. It will be your longest fix. And again, economy of scale. There's a lot of equipment that goes into patching these things and replacing these, and it's an amazing amount of dollars that we can save, or that are represented when you're talking about this economy of scale. If you're running through multiple panels, if you're running on either side of a joint with some bad concrete, that's your best case scenario, is to do a full depth patch. Some considerations there, your concrete materials. Smooth dowels. One thing that we switched to in Minnesota actually is putting smooth dowels on both sides of your concrete patch. And the reason for it is why lock one? Concrete has to move. It's going to move no matter what you do. So you double your success in terms of creating working joints, of making sure that everything is aligned and everything else, by putting smooth dowels on either side of it. If you lock one side, that becomes your only working joint. And going back to the South Dakota project that I brought up before, they have the stretch of road that we're working on, like I said, use the dowel bar inserter. They've got bars all over, they've got lock joints. Their specification calls to install if you install a full depth patch on a mid-panel crack in the middle of the panel without using an existing transverse joint, you go ahead and you put number 9 or number 10 tie bars on either end of that patch instead of smooth dowels. Last week we poured, and 4 of our patches cracked almost within a day. We haven't even opened the roadway up yet. And it's because they have this issue with the dowel bars, they have an issue with lock joints, and we put in new, fresh lock joints, and we don't know if it's the 10 joints before it, or 10 joints after it, or 1,000 feet, or what, but everything is locked up within there, and with that weak spot of concrete that's trying to cure out, that's where we're seeing the everything is falling apart on it. In the next day, we switched over to smooth dowels to create working joints, and we haven't had an issue yet. It's little things like that the partnership of us and the DOT discussing it, knowing the history of the road itself, brings up solutions that you might not be aware of. The sizing of the patch, go beyond the deterioration. I would also urge going beyond the existing transverse joints. If there's existing dowel bars in it, and cutting through those dowel bars and trying to drill next to them and epoxying or grouting in the bars, it's a mess. You really, if you're looking at an 18-inch bar that's existing within it, go a foot beyond that existing transverse joint, so that you're drilling into fresh concrete. It doesn't matter if you're drilling into deteriorated concrete. It's already deteriorated with 8, 12, inch and a quarter, inch and a half dowel bars in it. So go beyond it and take a little bit more. The minimum length at the 4 feet. Perfect example, Travis and I worked on a project for the West Virginia DOT, and I believe it was 6 foot, right? The standard specification, and there was a lot of partial depths that we had figured for that project. When we got out there, it was too far gone. The partial depths were too far gone. It wasn't going to be the fix that they wanted. They were investing a lot of money in doing concrete repair, followed by a diamond grinding, a joint sealing. They're running the whole gamut because they didn't want to touch the road for another 20 years. We met, we discussed it at length, and one of the things that we suggested was, hey, all over the country, we do 4-foot patches. We don't do 6 foot. I know you have a 6 foot minimum, but if we're looking at an area here that's got some bad, what you wanted to do as a partial depth, a 2 foot wide partial depth, and it's going all the way to the subgrade, a 4-foot patch is better than, a 4-foot full depth is better than doing a partial depth that isn't going to last. And I think the only bad thing about that project is that we didn't have an opportunity to talk in the design phase about that, to look at it and say, we might be too far gone on these partials. But other than that, I really believe it was a successful project. I think we're in good shape, and it's actually, he's the reason why I'm here, because he called and asked if I could come and talk about it, because it was such a successful project. And it wasn't because Interstate Improvement is the best contractor in the United States, because like I said before, unfortunately, a lot of our competitors are equally as skilled as we are. It's just simply partnership. It's discussing it. It's working through the problems and knowing that we have a problem, and that as an industry, we don't want to give you a half-assed project. We don't want that project that we do to be the last project that West Virginia does in concrete repair. We don't want them to go, well, that tool is gone out of the toolbox. We're left with an asphalt overlay on this concrete roadway. Nothing against asphalt roadways or overlays, because I don't know enough about them to bash them. Give me some time, I'd come up with something. But again, as an industry, we're not looking for everything. We're looking for a piece of the pie, and we want, when we do get that piece, we want to do it correctly. We want to work with you guys and everyone else to get it done correctly. I can already see here that I'm running over, so I'm gonna whip through this. And again, reach out to me at the end here. I'm going to have my contact information. You reach out to me with any questions, and if you want this slideshow, I'll email it to you with some of the do's and don'ts. Going into the diamond grinding, for us, this is really something that we like to add to every one of the projects that we're looking at doing. To eliminate that faulting, to take that thin layer off of everything, to clean it all up, if for nothing more cosmetically, to have the traveling public not see that quilt-looking patchwork of stuff after it's done, even if it rides like glass, that diamond grinding makes cosmetically looks very appealing and has so many different beneficial factors to it in terms of the friction that we're looking for, that we talked about earlier, that we're going to continue to push with, was it Andy? On getting listed as an alternative to that high friction surface treatment. But there's a lot of definite benefits to the diamond grinding, especially when you have a 50 or 60-year-old pavement. Just some pictures of a fine surface of it, what it looks like. You can see that corduroy look. I'll just kind of hit on a couple of them. They do cost substantially less than overlays. If you were to jump on a concrete roadway that, I know it might sound crazy, but if you were to jump on a concrete roadway that was only 15 or 20 years old, instead of 50 to 70 years old like we're currently doing. But if you got on a concrete roadway at 15 or 20, did a couple of minor patches, and diamond ground it, the extension of the life of that would certainly get you into that 50 to 70 year range in terms of your overall life cycle of that. It would give you that 30, 40 years that you're looking for. Even doing a minor or major repair on the 50-year-old roadways and diamond grinding afterwards ensures that 15 to 20 year fix. Takes away all of that faulting, takes away the noise that people don't like about concrete, takes away so many different things, and really provides a smooth, nice transition road. Again, you can see some of the problems that's addressed with. Contrary to what some people might think, we can diamond grind asphalt pavement. We do it on almost every project when we have to feather grind into the shoulders, when we have to grind through the taper from the transition from asphalt to grinding. So it is another avenue to look at. And again, the unacceptable noise levels of concrete, the grinding all but eliminates that. There's a next generation grinding surface that I could talk about for hours as well, but that puts us down below our asphalt competitors in terms of noise. Eliminate that joint faulting that you see here. That's the big thing with the diamond grinding. And it preserves the pavement by just not having those heavy trucks that we have so much more of running on these interstates now. They don't get hopping. You don't see the black marks from the trucks bouncing over everything. We can usually provide a 60 to 70% improvement over the pre-grind profile of an existing road. And if you're looking at wanting to discuss average pricing on grinding, on what you think a square yard would cost, that's the phone call that you make to the IGGA or you make to myself or one of my competitors, and you just say, hey, looking at 100,000 square yards, I'm looking at 50,000, I'm looking at 400,000 in this type of an area, and our industry will ballpark it for you. We'll give you a very conservative estimate that allows you something to go off of and continue with that design phase. And a little bit of a hint, as contractors, even though we're spread out all over the country and we might come 1,200 miles to do your work, if there's things like concrete repair, diamond grinding, joint sealing, we have to show up. We have to look at the project before we bid it. So asking us to come out on our own dime to sit down and meet with you to discuss a potential project that might be designed is not asking too much, because we're going to come out anyways. If you advertise it in 2 months, I'm still going to have to fly out there, drive it, look at it, measure joints, that sort of thing, kind of try to determine, look at how hard the aggregates are. I'd rather just do it with you and with some of my competitors. So joint and crack sealing, I'm gonna kind of breeze through that because I am running way over on time. Guidelines for the resealing joints: if you continue to reseal joints if they are originally sealed, they were sealed for a reason. Last thing I have, controlling the costs. If you know the history of your road, things like that, it was designed with a faulty dowel bar inserter, that sort of thing. Know that history. Know what you're looking to get out of it. During the design phase, investigate, do the coring, really look at things so that we're not surprised when we go out there. And be conservative with your estimates. Allow yourself a little cushion, because I'm sure you guys know more than I do that what you design and when you actually get to build it could be years. And concrete, if it needs repair, it doesn't magically fix itself, and it doesn't completely stop either. It starts and it continues to go. Schedule, the flexibility, completion dates, those sort of things go monumental ways when it comes to the pricing that you're going to get. There's a huge influx and discrepancies of pricing all around, and giving that schedule flexibility. Your allowable work times, your work zones. We're volume contractors. We need to get a certain amount of volume. We need to get a certain amount of cubic yards poured every shift. Otherwise, we're not making money. And if we're not making money, we're not delivering the product that you guys want. Something along the lines of when you're pouring concrete, the difference between a 9-hour work window and a 12-hour work window is probably about 50 to 60% more work getting done in the 12-hour work window as opposed to a 9-hour work window. That's 3 more hours that we have. That 3 extra hours is everything. I mean, the 15 minutes is everything. That 15 minutes is the difference, is 10 more yards. That's 1 more concrete truck getting dumped. So different tactics, looking at, if we worked on a project east of Oklahoma City last year where both directions, you had 16-hour work windows, but you had to be off the road during the rush hour. Obviously, with it being on the east side, when we're going eastbound, we're off the road at 3 in the afternoon till 7 or 8 o'clock at night. When we're going westbound into the city, we're off the road from 3 in the morning or 4 in the morning till 8 o'clock or 9 o'clock in the morning. We avoid the rush hour, but just that difference is cutting the project duration in half, cutting your guys' costs in terms of the number of people you need out there inspecting, the time that you need to be out there in half. And probably, I can't say it would cut the complaints in half, because you're gonna get them regardless, but it does do a lot. And those are the little nuances, the little things that you can ask our industry and just say, what would happen here? What if I show you a design, what would you need, or what could you give me that would lower your costs? And the guys that I work with and the guys I work against are all pretty open about it, and they'll tell you flat out, we need that more time and everything else. And again, in capital, because I can't stress it enough, economy of scale, it's everything. The more you want done, the lower your prices are going to be. It's just that simple. Anytime you bid a project, you're likely going to have a handful of local competition and a handful of national competition all coming together to bid against each other. And the larger the project, the more concrete there is to pour, the lower your prices will be. Even if that means you have to pick 2 or 3 roads and pair them up together, it's still gonna bring in substantially cheaper costs. So that's what we really need to look for. Here's the contact. The IGGA, John Roberts is the executive director. Like I said, Larry Schofield is here. And outside of that, my contact information below that. And again, I plan to sit in with Larry over the next couple hours at the IGGA booth on the exhibitor side. If you have any questions or something like that, 100% ask me. I encourage it. So if there isn't any questions, that's all I have.
Thank you. You talked about sounding and coring for investigation. Have you seen any success with maybe a middle ground of non-destructive testing, maybe GPR or anything like that?
Personally, I have not. Not to say that there wouldn't be. And maybe Larry could shed a little more light on it.
The GPR at highway speed, where you're talking about materials associated with distress, you can pick up that very easy. When you get down to the delamination, you're probably going to have to be spot specific on that part of it. So as a screening tool in the design phase, it's actually outstanding to do. Not many people do that. Hopefully someday everybody will do that. But when you really get down to marking the patches, you're probably going to be back to sounding.
Oh, everybody give him a hand. Thank you, Sam. I have a great committee. They keep me on staff. Okay.